Another way in which we can manage capacity is to reconcile it with demand. And so we've got three different scenarios here. We have um, a level capacity plan, and in this case we have demand for a product which is going to change over a period of time. So this peak here would possibly be the December sales period, and the capacity to supply will remain constant throughout that period. So in this first month we're actually producing more than they're demanding until we hit this period, and then it's the reverse. But because we've produced more here, we're able to cover this period here. So we've got often use this in not so much in garment manufacturing, although it does apply. It's more in heavy industries like car manufacturing, where you've got, or shipbuilding, for instance, where you've got to have. It's very hard to retool a factory to supply according to changing demands. So they plan, their production schedule 6 months in advance, perhaps, and they said this is how much we expect to produce every day. The textile industry or garment manufacturing is a little bit more flexible in that sense, so it might follow this second model, the chase demand plan, in which the production of garments is going to match, to a degree, or as closely as possible, demand for those garments. Also known as just in time, or making just enough. And the third model is a hybrid managed system, which is a combination of the two. So for some periods we might have consistent production and demand, and then we can alter the output, the manufacturing, if you like, to suit any particular demand. So it's managed, if you like. If we look at this numerically, let's say we've got a factory, we want to excuse me, we have a starting inventory of 100 garments, so we want to maintain that 100 garments regardless of how much we produce or how much we supply. Our warehouse must always have 100 garments. So in our first period we expect demand to be 150 garments, second period 160, 180. So we've got fluctuating demand, which reflects this little pyramid there, with a total of 960. If we look at the level strategy, then we've got our demand, which we just looked at. Our planned production is going to be consistent at 160 units per period or per month. The advantage of that is that we can plan our scheduling, we can plan out the staff we require, the machinery we require, the deliveries we require are all planned. And the stock on hand at the end of each month is consistent. So we're always going to have 100 garments in our distribution center or somewhere in the system. Level strategy. In the second scenario, the chase one, again we've got demand as it was before. Our planned inventory is consistent at 100 units, but this time the production, the amount we're going to produce every month, will match the demand. So what that means, in the first month we need to employ enough people and machinery to produce or supply 150 garments. Then we're going to have to ramp up production for these months and then drop it down again. So a much more flexible approach. And the third one, a hybrid system. With the hybrid system we've got our demand as it was in the previous two examples, but we've set our production at 140 units for the first 3 months in order to satisfy demand, which in all 3 months is in excess of planned production. So even though we're making 140, we're short by 10 units. We're going to pull it out of the inventory that we've got, and the same for those first 3 months. So unlike the first two scenarios where we always had 100 garments on hand at any given time, this time we have a fluctuating level of stock in the warehouse, and this might suit some instances or some seasons better than others. So it's a combination of the two. The risk, of course, is that if you get these plant production, or if you've got problems with your production or demand exceeds our forecast, remember these are forecast sales, then you may get caught short and run out of stock. All of these, or any changes or any dramatic change in demand is actually going to reverberate through the system. And so it has a particular name. We call this the bullwhip effect.